Hello, I'm Robert, and this time I'm helping people who are scared of various things, fact-checking and science blogger. And this time it's about if you're scared and you think that someone is in a big conspiracy and hiding the night sky, and there's this. I'll talk about this in a minute in a separate video, but there's this chap who's saying that we've got a debris field, whatever that's supposed to be, that's about to hit Earth. And so, and then he claims that the CIA know all about this debris field, and nobody else does. And it's just not possible to hide the night sky. And so this is the Atlas, the Asteroid Last Alert System, which is every few days it scans the entire night sky. You can watch it doing its stuff. Now here it is. It's just finished its work for the day. It says ventilating dome, and you can see the last pictures that it took. This is one of the last pictures it took during the day, and you can see it's got to the end of it's all rather washed out and not the best of pictures, but they keep on doing it until the very end, and you get these streaky patterns and things. And this is and then there's another one, and that's that they've got two of them looking at the sky, and the idea is to get a kind of binocular vision. And so you can estimate the distance if anything happened to be fairly close. Anyway, they discover a lot of the asteroids, and they are optimized to spot any that are headed towards Earth. Then Atlas will be one of the first to spot anything like that. So those are the last of the observations that they did last night. And that's one telescope, and that's the other one. And they observed the entire sky with huge swathes of it at once with very big cameras. And so you can just go and look at all those pictures yourself. You can go and watch it online and watch it taking those photographs. You see the photographs if you watch it online, probably before most of the astronomers see them. So it's totally automated. So there's no way that this can be hidden. The CIA have got they're spying on the astronomers. There's no point. You just need to go to this webpage and they can see exactly what they're doing. So it's all rather ridiculous, this idea that you need the CIA to be spying in order to find out what's happening in the night sky. Of course they don't do astronomy themselves. That's a daft idea. And this gives you an idea. This is actually not an asteroid, but it's the Chinese mission. What's it called again? But the one, Tianwen, or however you pronounce it, it's on its way to Mars. It's the first Chinese mission to send a spacecraft to Mars. It's going to land a rover on the surface, a small one, a bit like Opportunity, and it's going to have an orbiter around Mars. And this was Atlas spotted it on its way out. See that those little, they took 3 images of it. It wasn't trying to track it. It just it's observing the entire sky, and so naturally it's not too much of a surprise that it catches it caught this as well. And if there's one coming the other way back towards us, it would be just like that, but in the opposite direction basically. Rather similar anyway. No, not exactly the same path backwards, but that gives you an idea. If you can spot one going out, you can spot one coming in. So there's no point in spying on anyone because it's all done in the open. Oh yes, and then I was going to show you this was a photograph that they took the other day, just to give a better idea when these were all very blurred out ones. You can see the sun. Because and this is, on this dashboard, that is an actual photograph, and you can see it's daytime sky, so it's now daytime there. And so that's a photograph of the night sky to give you an idea of the weather and stuff, and of the sky from there. And that's a photograph it took when it was darker the other day. And so yes, I was going to show you. This is once those photographs, then obviously astronomers and amateurs will go and look at them. And recently there was a story about a couple of young schoolgirls in India who discovered an asteroid by looking at those photographs. But they also get them automatically discovered. So you have this software that just looks at the images, and as you see, it doesn't just take one photograph. It takes a sequence of photographs in each section, so as to make it easy to find something moving. And that's how it took this image. That one took that one image because it took 3 photographs of that section of the sky. So the software automatically can pick up and say, oh, those asteroids are quite easy to pick up, and comparatively, except when you've got glitches that you can hide behind and stuff. But so there's this automatic system that takes those images and automatically puts any asteroids it finds, any moving objects, into this table if it turns out to be a near-Earth object. So it'll automatically check, is it possible? So here's one of them. Now this is all done automatically. So it's done this. We'll wait for it to come up. So it's quite fascinating what they do. So there we are. There was looking at orbital elements, periodic distance. This shows the magnitude, and this is the close approach plot, which shows so they've only got a few observations. Like if I go again to this one, then suppose those were all the observations you've got, just those 3. Then 3 are enough to I think 3 are enough for an orbit. I have to double check this. I've got this on my page somewhere. But so it would. But so you've got those 3 observations. You're looking at this in 2D. So it's a thing moving in 3D through space. But we're just seeing it in 2D. It's sort of like someone has thrown a ball across in front of you, and you only see 3 positions of it. Then they ask, and you don't know which direction they're pointing it or anything. And then you've got to try, and then someone asks you, where is it going to land? Is it going to land in the hole? It says a golf ball, and someone's hitting with a golf club. And you've got just 3 images of this golf ball flying through space. Then you've got the question, is it a hole in one? Then it's very unlikely that you would have enough depth and enough position understanding of those 3 positions to be able to figure out from that, even with very precise timing of those 3 positions, to figure out if it's going to be a hole in one. There just isn't enough information there. So at this stage, it's just 3 observations, or just very few observations. Then they come here and they just don't have enough information to know. So for instance, this is the distance from Earth's orbit, and that's 0.05 AU, which means it's fallen within the limit of a near-Earth object. And they don't know where it's going to be. It could be there. So those are all the possibilities for how close it gets to Earth's orbit. That's not how close it gets to Earth, but how close it gets to our orbit. We could be on the other side of the Sun at the point it crosses close to our orbit. And here we are, close approach time. So they've flagged it because it's got a close approach date. If this is a real object, they don't know yet if it's a real object, but they've still found a date. And that's the 31st of July. Don't worry about it. This is nothing going to happen on that date. And then they have the close approach distance, which is quite a long distance. If you look, 1,000th of an AU is still quite a long distance. Even the 10,000, and that's 10,000, and that'll be 100,000. So let's put that up here and do the calculation. Now 1 would be 1,000, or 10th. That's 100th. That's 1,000. That's 10,000. So 0.01. Now I'm going to turn that in. It's just going to be me. Not going to tell me anything out there yet. 0.01 space AU in kilometers. And then that is 14,000 kilometers. So that if it got as close as that would be quite close. 10 to the minus 4. 10 minus 3 would be 140,000 kilometers. And then the most likely place way up here is that it's It's and it's more like 1,000,000 kilometers away from Earth on that date, if it's a real object. So they don't know if it's a real object yet. And then, so then you'll get astronomers and they come and look at this and they say, okay, I wonder if this is a real object. And then they'll be particularly interested in the right ascension and the declination and the anyway, they'll have other information there they'll be looking at, and they'll look at this page. In fact, they will look at that bit, right ascension and declination, and anyway, so I don't do any of this observation. So I'm not an observational astronomer. I don't know how they deal with this, but if you were an observational astronomer who is involved in this program, then you would be going to here, or maybe you go to the daily telegram from the Minor Planet Center. They put out lots of telegrams which are automated. They're no longer real telegrams, electronic telegrams. I think they're called something else now, electronic circular or something. And there used to be telegrams back in the day. And so the astronomers then will get this alert, and then they go and get out their telescope and they look wherever it is in the sky that this thing is supposed to be, if it's real. And so that is how this works. And again, and then if the astronomers spot anything, then they will email it or communicate it in whatever way to the Minor Planet Center, which will then add it to the list of observations. And then that'll, first of all, they work out if it's a real object. And if it is a real object, then it goes into the near-Earth objects table, and then you get these observations. And then you have people with just ordinary telescopes, backyard telescopes. They don't need to be anything fancy. This big asteroid alert telescope, I mean, it's not that big actually, but this compared with the huge ones in Hawaii, but it's optimized for looking at the looking for asteroids, and it's constantly looking around the sky in the right kind of way, optimized for looking for them. And so for that you need a large camera, and you need a very sensitive image of a large area of the sky at once. But I think it's larger than I'd have to look it up what size it is, but you talk about a really big area of the sky, and it goes there, and it takes lots of photographs, because the aim of Atlas is to photograph as much of the sky quickly as possible at a very high sensitivity, in order to be able to pick up very faint objects moving quickly compared to planets and things. And so it's optimized, and it's optimized also particularly for ones that could be on Earth trajectories. So this thing is every night it's out there taking these photographs automatically. It just goes click, 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 and it takes them 3 at a time, I think it is. You have to look up these details, but that's going on every night. These things automatically looking for asteroids. So it's absolutely impossible to hide anything. You can just go and look, and you can say, oh, I'm interested in this little bit of the sky, where it photographs the entire sky every 3 days. I'm interested in that little bit. Go and look what it photographed there. And it's the best way. Much better than anything you would have in your backyard if what you're interested in is asteroids. But then once it's found this asteroid using a very big sensitive camera, then you can get your backyard telescope out and focus well down. And then what backyard astronomers are good at is they can focus on a tiny little area of the sky, and they just look at it and then see, is there an asteroid there? And so that's how this works. And then you have some professional astronomers, and you have some backyard astronomers, and they don't need especially big telescopes to do a lot of the tracking. And I mean, you're talking about a telescope that cost a few $1,000s, but a keen amateur astronomer then would have that, and also our grants from some bodies. If you want to become part of the asteroids searching, and you've got the right credentials and everything, then you can get a grant to buy a telescope in order to search for asteroids. There are quite a few people around doing that. So That's all I want to say, and then I'll do a separate one about this entire debris field bullshit. Oh yes, one more thing I wanted to do. Oh no, I'll explain that in the next video. So I'll do another video in a minute about the why we're not at any risk of a debris field. Whatever that is, it's not even astronomical. It's not even an astronomical thing. So I'll do that in a minute. That's my next video. And usual thing, I'm doing this mainly to help people in Doomsday Debunk group in Facebook, but anyone else who's scared of the same kind of things, and people in Twitter, I share it on Twitter, and I might share it on YouTube. I'll probably add it to this thing on Quora, or do a separate one. Anyway, if you want help with this sort of thing, and also if any of you are able to help others, so for instance on this particular topic, then obviously I'm not expert on it. I just know I found out about these things, but I'm not one of these people who go out every day watching asteroids. If one of you watching this is one of those people who goes out and goes watching asteroids and searching for these things, then you might be able to come and help us in the group and just reassure people and say from your own experience, oh, I'm outside, go out watching asteroids myself. I know that quite a lot of people out there do that, and maybe if any of you happen to watch this, might like to join our group and help reassure a few people from time to time that you don't need to be scared. Anyway, so we welcome anyone who's got good understanding. We really welcome debunkers who understand what they're talking about. I can just put people right and just say straight, plain how things are. And then anyone who's scared, then do come and join our group. And if you're good at reassuring scared people, it's a friendly group. It is autism friendly and it is bipolar friendly. So if you're manic or if you're autistic, then we still we accommodate you as best we possibly can within the rules of the group, and the rules of groups are set up to be as far as possible autism, and we have lots of autistic members, about a quarter autistic. They tend to get very scared of these things, and then that's a very rough estimate. And then we have quite a few who are manic depressive, bipolar, and that seems to be another thing. But I mean, this affects everyone, so I mean, don't get the impression that it's only people who are manic depressive and autistic. Also, people who are also tend to be people very empathic also get very scared of things. I think those would be our three main groups. People who are very sensitive and empathic, people who are autistic, and people who are bipolar. Then there's a very high prevalence of all those three in our group of both the scared people, and then once they get over it, they're there. Quite a few of them are there helping the scared people. So anyway, that's me done for today, for this one, and now I'll do the next one. I will add the link to this in the description, obviously. Oh, and do join the channel if you want to see more videos like this.